Hi everyone, what's up? Today I want to show you how you can integrate odd powers of sine and cosine, okay? So let me give you an example. If you have the following integral, so you have sine to the n theta d theta, where n is going to be an odd number, sorry, not an even number. I was going to write an even, but nope. This is an odd number, odd n. So what do you do in this case? Well, there's a really, I would say, an easy strategy. As long as you know how to approach this, as long as you know about this strategy, I think integrals of this type are really easy to solve. And really, the only thing you need to use is the trigonometric identity that goes that sine squared theta is going to be equal to 1 minus cosine squared theta, okay? So something really nice is going to happen when you use this formula in here, okay? So let me give you an example. Say that you have the integral of sine to the third power, theta d theta, okay? So what do you do in this case? Well, if you use this formula, you can factor out a sine from this sine to third power, and you're gonna get sine squared. And you can rewrite sine squared in terms of cosine, okay? And then you can do use substitution. So you get this. This is gonna be sine. It's gonna be sine theta times to keep the integrand the same. This would be sine squared. We know sine squared is gonna be 1 minus cosine squared theta d theta. And now look at this integrand. Hopefully you notice hopefully you can notice that if you let u be equal to cosine theta, then you could just simply use substitution to solve this integral, and you get an answer for sine cubed, okay? So I'm gonna do substitution. I'm gonna write it. Where am I gonna do it? I'm gonna do it up here, okay? So let's say that we're gonna let u be equal to cosine. I'm just gonna let it equal to cosine theta. Then we get that du, it's actually gonna be minus du, is gonna be equal to sine theta d theta, okay? Remember the derivative of cosine gives you a negative in front, so you can just simply move that negative to the other side, okay? So now, if we want to rewrite this integral, we just do the following. We're just gonna get that this is equal to the integral. So we have sine theta d theta, we know that it's just gonna be minus du, so I'm actually gonna move this minus in front. And now we have 1 minus, so 1 minus u squared. Remember, we let u be equal to cosine theta. So we have u squared du, okay? Du, it has a negative in front, but we just move it outside. And now this integral is really easy to solve. Hopefully you know how to do this. If you want to solve this, well, you can just simply, you could either, I don't know, just distribute the negative or just do this one. And you're going to get that this will be equal to minus u. And then this will be plus u to the third power divided by 3, okay? This is just the power rule. You get plus c. And now you simply need to plug back in, plug cosine theta into this expression. And you get that, so I'm going to write this over here. This means that the integral of sine cubed theta d theta will be equal to, so we're going to have cosine cubed theta divided by 3 minus cosine theta and any constant of integration, okay? So yeah, this is what you get for sine cubed, okay? Now what if you have, instead of, I'm gonna do a quick example down here. So what if you have the following form? So this is how you can use this approach to compute any odd power of sine, okay? Now what if you have the integral of, let's say, cosine n theta d theta, where n is even. So you have so you have odd n. What do you do in this case? Well, actually, you can just do the same thing. Instead of using this equation for, solving or isolating cosine in this equation, you can just instead of isolating sine, you can just isolate cosine, okay? And so you get that, you could rewrite this, so I'm gonna do the same example. The integral of cosine to a third power d theta, well, this will be the same as the integral of cosine theta times 1 minus sine squared. So sine squared theta d theta. And now you do the same thing. You let u be equal to, I'm gonna write the entire thing again. So yeah, you let u be equal to sine theta, and then you have that du is gonna be equal to cosine theta d theta, And once you have this, well, it's really easy to see that this will just be the same as the integral of 1 minus u squared du. We don't have any negative signs coming out of that derivative of sine, so we're good. And then that will just simply be equal to, so this will be u, we know u is equal to sine, so this will actually be minus. I'm going to write the entire thing out. So this will be, we know this integral is going to give us u to the third power, so that is just going to be sine to the third power theta divided by 3, and then you have plus sine theta plus c, okay? So this is pretty much how it goes. Hopefully you can see that it's really easy. You can use this wonderful Pythagorean trigonometric identity to solve for the integral of any power of sine, for any odd power of sine and cosine, okay? So if you have cosine to the third power or sine to the third power, well, you can just use this approach and it's gonna work, okay? I'm sure there are many other ways, there are many other identities that allow you to rewrite powers of sine and cosine into other functions, and then you can integrate those functions and get an answer. But this is probably the easiest way, okay? And this is probably, a way that you wanna know about, okay? So yeah, that's been the entire video. Hopefully you enjoyed it, you learned something, and yeah, see ya.